Hello everyone, my name is Devan Sharma. I am Account Technology Manager for Tessent Embedded Analytics team. Today I'm going to present how smart monitors and embedded software can boost your SoC debug. So before we talk about smart monitors and embedded software, I think we need to know why do we need these monitors basically. So if you think about an SoC, there are kind of complex, these are complex SoCs, and these have their own application requirements. In addition to that, each application operates in its own operating condition as well. So there are some challenges, which are very application specific. The effort required to basically validate, optimize, and maybe debug is quite a lot, and that gets increased with the complexity as well. So there is a need to actually have more visibility on how your SoC is behaving when when they are under real-time constraints. So smart monitors provide you a mechanism whereby they can provide you a lot of visibility into your SoC, and embedded software can take this one step further, and they can basically extend the life of these smart monitors and can provide you in-life analytic solution. So talking about smart monitors, what exactly they are? Smart monitors, basically what we provide is the suite of RTL modules which get embedded into your SoC, and these smart monitors provide you non-intrusive observation into your design, how they are operating when you run the real-time software on it. So idea is basically to provide more visibility into your software, how it's performing when you are running it on the SoC, and idea also is to basically reduce the the validation costs, because you will be spending less time on debugging and tracing your SoC. Also it allows you to optimize your software as well, and then another capability is you can collect the data provided by these monitors, and you can basically enhance your next generation of products as well. So you can improve on your previous generation of products and provide better products to the market. And the data produced by these monitors can be accessed by various ways. So one of the ways is obviously to use the hardware interfaces which are provided, but there are other ways you can access the data provided by these monitors. This include embedded software. That's another way you can get the data. And in this sky blue color, you can see the various type of monitors we have. So you can use the one which is suitable for your application. So in terms of RISC-V enhanced trace encoder, we do have support for supporting the RISC-V cores if you want to trace. In fact, it was Siemens who donated initial specification for efficient trace standard for RISC-V, which was later refined and ratified by RISC-V International. One of the key feature of Tessent enhanced trace encoder is the cycle accurate instruction trace, and this allows you to know exactly on what clock a particular instruction was executed. That way you can basically look at the optimization side of your software. So now taking the practical example, so this is one of our customer, Picocom. They use these monitors. Basically Picocom operate in 5G domain. As you know, 5G processing is very complex. They needed basically to have software upgrade in the field. So that also possesses, great challenge. And then in addition to that, because they have to operate in the field, they needed to interoperate with different kind of antennas. So there were some problems which they couldn't reproduce in the lab, or they wouldn't encounter in the lab. So it was quite challenging for them to actually debug some of the problems they were encountering. So what they did was, they used embedded analytics from us, and If you look at the graph, in one of the graphs we are showing there are 3 red dots. So what this is indicating, by using embedded analytic monitors, they were able to identify a point when multiple initiators were trying to access memory at the same time. Now, if you leave this scenario in your SoC, what is going to happen is it's going to cause memory degradation issues. So which is going to overall impact your performance of the CPU. And in the second case, second picture we are showing, which is CPU performance loss, they use our bus monitor to calculate basically the minimum, maximum and average, the average cache traffic. So by monitoring them, they were able to detect, how much time was spent in this cycle and accordingly identify the CPU performance there. They were able to basically get rid of the problems they had in their system by using embedded analytics. Now, going beyond just the in-lab, if you want to do in-life analytics, we have this software which is called Tessent Embedded SDK. Tessent Embedded SDK is highly optimized software library which is available in source code. It extends the life of these data monitors to in-life analytics. So by using embedded software SDK, you are able to create an application which can run on a supervisory CPU, and it can provide you a lot of useful data for analytics purposes and also monitoring. So you can use this to create a self-contained on-chip monitoring application. So let's take a look at the examples here. So here what we are showing is an SoC which is using monitors from Siemens running the embedded software. So in this case, it's a mobile device, and what you can do is you can basically do a lot of edge analytics. So when you are doing that, you are not sending all the data which you are collecting from these data monitors. So what you are doing is you are doing pre-processing and analytics on the data provided by these monitor, and you are only sending the relevant data off chip if that is required for your application. So this is one example where the combination of smart monitors and embedded software can help you to create the edge analytic application for your application as well. So in second example, you can do real-time error detection and solution because these data monitor is present in the device. So they are continuously providing you data about the real-time data about how your device is performing under various circumstances or various loads or real-time constraints. So when a particular when the software which is running on them can detect a particular condition, you can trigger it. When it can detect some sort of error, it can trigger certain events. And then embedded software can communicate that to off chip if required, and then you can analyze it why this error was caused and accordingly modify the problem and your code if that is what will help to solve the problem. So that was the second example, and in third example, what you can do is basically you can have a mechanism whereby you can continuously do telemetry testing and detection of your hardware, whether it's performing properly or not. So in this case, just for example, let's say you are using this application to see whether you are getting latency numbers correct for a particular transaction or not. So if that is not happening, you can alert the system and accordingly modify the code, and you can run these kind of testing within your system basically. So in the end, I would like to say that by using the smart monitors and embedded software, you can basically manage the complexities of the large SoC because the smart monitor provides non-intrusive observation of how your software is behaving when you are running that software in real time. And with the Tessent Embedded SDK, it can take that particular monitoring to next level by providing you on-chip real-time monitoring. You can do remote access on that. You can do low latency performance, and capturing a lot of logging can be done. And in case you want to learn more about test and embedded SDK, there is webinar which is available. You can log on to website and basically learn more about embedded SDK. Thank you.